As a reminder, for a variable to be a potential confounder, it has to be associated with both that independent variable as well as that outcome variable. And in order for a variable to actually confound a relationship, it has to be unequally distributed among the groups that we're comparing. So for example, we talked about that relationship between alcohol consumption and the development of lung cancer. Well, we know that smoking is a potential confounder in that relationship. We know that essentially people who consume alcohol are probably going to be more likely to smoke, and so you're going to have more smokers in that alcohol consuming group. And then in terms of those who develop lung cancer, we know that people who develop lung cancer are more likely to be smokers, and so you're going to get more people who smoke in that lung cancer group. That confounder has to be distributed unequally among the groups that we're comparing. Now, we're going to talk about this later, but if a factor is not unequally distributed among the groups we're comparing, then you can't have the issue of confounding. This is essentially what we're doing with a randomized control trial. We're making sure the distribution of variables that could potentially be confounders, that is going to be equal amongst our treatment as well as our placebo group. And then lastly, a confounder, it cannot be on that causal pathway. It cannot be the direct results of the exposure variable. So if, for example, here, if you have an exposure variable of, let's say, fat consumption, the variable cholesterol level, that would be on this causal pathway because that fat consumption might result in those cholesterol levels. And therefore, because it falls on that pathway, you would not consider that cholesterol level variable to be a potential confounder. So let's look at an example. We are going to, in this hypothetical study, look at the relationship between gender and malaria. And so maybe we hypothesize that male gender is going to increase the likelihood of getting malaria. So we're asking, are malaria cases more likely to be male? What I would do is I would set up my 2x2 table, and I would consider in my exposure group that would be male given my research question, and the unexposed would be female. And I would put my cases up on this column and my controls on this column. And then let's say that this is what the data looked like. I ended up with 88 male cases. I ended up with 62 female cases, 68 males without malaria, and 82 females without malaria. So we set up this 2x2 table, and given that this is a case control study, we would calculate an odds ratio. So when I do that calculation, this is what my data would look like. You might want to pause this video and calculate it for yourself to make sure that you get the same number. So when I plug in the numbers, what I find is that I get an odds ratio of 1.71. I would interpret this by saying cases are 1.7 times as likely to be male compared to the controls. Alternatively, cases are 71% more likely to be male than controls. But I would describe this as a positive association. Now, in the real world, if I was actually looking at this, I would calculate my 95% confidence intervals to determine whether this result I got was statistically significant. Remember that you have to have a statistically significant result in order to determine that that relationship isn't due to chance. So to conclude, is there an association? I would look at that statistical significance. In this case, I do find that I do have a statistically significant result. My confidence interval is on the other side of 1. It does not include 1, which would be the null value. So in this case, I do have a statistically significant association, and so I would conclude that there is a positive association. My odds ratio is 1.71 in terms of gender and disease status for malaria. So it does look like there is this positive association here. I might determine that, yeah, based on my research question, that that it looks like there is a positive relationship between being male and the development of malaria. In this class, I'm not going to have you calculate confidence intervals. I would give these to you, but for this module, I do want you to be able to calculate those measures of association, so an odds ratio or a relative risk. But based on this information, I see that there is an association, and that association looks like it's a positive association. So I might be concerned about the development of malaria in males compared to females. However, I want to pause. And as a researcher, I want to think, okay, I'm looking at this relationship, but could there be some other variable out there that I didn't consider that might be a potential confounder? Could I have issues around bias in my study? In this module, we're focusing on confounding. So do we think that there's some third variable in our data that we've collected that could potentially be a confounder in this relationship? More specifically, I might want to think about the variable working outside as a potential confounder for this relationship. So let's say that I'm looking at this relationship between gender and the development of malaria. I am going to consider working outside as a potential confounder. So how do I actually detect confounding? So I should consider that working outside is a potential confounder in this relationship between gender and malaria, because what I know is that, and we're going to do these calculations, that males are probably more likely to work outside, and people who work outside are probably more likely to get malaria. So just thinking about these variables, working outside could definitely be a potential confounder. It's probably going to be related to my exposure, which is gender, and my disease status, which is malaria. The next thing I need to think about is when I calculate the strata-specific measures, I need to think about, are those measures the same? And we will look at an example of what we mean by this. And then the third step in actually detecting the presence of confounding, we need to compare what we call our crude association to our adjusted association and see if there's a difference of 10% or more, and we will get to that in this video. So we are looking at working outside as a potential confounder in terms of the relationship between male gender and malaria. We hypothesize that there's probably some association here and there's probably some association here, and we know that working outside isn't a biological consequence of male gender. So how do we determine whether the potential confounder is actually related to the exposure or the outcome? What we would do is we would set up 2x2 tables to look and see, is there a relationship? So for example, we would set up a table looking at the relationship between our exposure, which is gender, and working outside, our potential confounder. So when we set this up, this is the data that we observe, and what we see is that we get 68 people here, 88 people here, 13 people here, and 31 people here. If I calculate out that odds ratio, I get an odds ratio of 1.8. So just based on that odds ratio, yeah, it looks like assuming that result is statistically significant, it looks like gender is actually related to working outside, and it looks like there's a positive association between being male and working outside. The next thing I need to do is look at the relationship between that potential confounder and the outcome variable. So up here, we looked at the relationship between the potential confounder and the exposure. Now we're looking at the relationship between the potential confounder and that outcome variable. So what we're looking at is our potential confounder here, which is mostly working outside or mostly working inside as the unexposed. And then we have our malaria status here. Our cases go here, our controls go here. And when we calculate that out, what we get is an odds ratio of 5.3. Assuming that is a statistically significant relationship, we would conclude that, yeah, it looks like there's a positive association between working mostly outdoors and having malaria. So based on these calculations, assuming they're statistically significant, it definitely appears that working outside is related to the exposure and to the outcome. So this suggests the possible presence of confounding. We know that the work environment, working outside, the potential confounder, does have a relationship with male gender, or a gender variable, and the outcome, which is having malaria. So we really have to think about, is this confounding the relationship, and examine this variable as a potential confounder. So the way that we kind of examine this, if we're using a stratified, what we call a stratified approach to determining the presence of confounding, when we're talking about a stratified approach, what this means is that we're using stratification to compare the odds ratios according to the level of that potential confounding variable. So remember, in this example, we're looking at the relationship between gender and malaria status. And we're looking at working outside as that potential, those working conditions as that potential confounder. So what I'm going to do is I'm going to look at the relationship between my exposure and my outcome in one level of that confounding variable. And then I'm going to look at that relationship between the exposure and the outcome in that other level of that confounding variable. So I'm going to start off by drawing my 2x2 table here in this top portion, and I'm just going to look at those who work mostly outdoors in terms of that relationship with gender and malaria status. So I am just looking at this top 2x2 table. I am just looking at those who work mostly outside. And when I set up this data, what I see is I get an odds ratio that is 1.06. Then what I'm going to do is I am going to look at the second level in that stratified data of this potential confounding variable. So now in this 2x2 table, I am just going to look at the people who work mostly indoors. So in this scenario, this top one, I am just looking at the people who work mostly outside. I am not including the people who work inside. And then in this bottom table, I am looking at just the people who work mostly inside. And when I set up this 2x2 table, I get the same gender variables here, the same malaria variables up here, and this is what my data looks like. Now, remember, when we just looked at the overall relationship between gender status and malaria status, we got an odds ratio of 1.71. Now we are going to compare that essentially to what we call an adjusted measure of association. And we are going to see, is there at least a 10% difference between our, what we call our crude odds ratio, which would be that original 1.71, and our adjusted odds ratio for this stratified approach? I'll talk about in the next slide on how to calculate that adjusted measure of association that we're going to use to compare our with our crude measure. But at this point, what we're seeing is that these strata are pretty similar to one another, right? So we get an odds ratio of 1.06 here and an odds ratio of 1.00. These are basically the same thing. So essentially step 2, I'm looking to see, are these strata, are these similar to one another?